Thank you all so much. It's so great to be here, and I just feel so fortunate to be a part of such a wonderful group of people who are willing to donate so much of their time and energy to learning about this disease. So my goal tonight is to share about our CSF biomarker data, sort of what we do with that data and what we've learned, particularly over the past year, as well as sort of where we hope to go in the future. And I'm not nearly as articulate as Dr. Johnson or as funny as Dr. Benlin, so I'll do my best, and bear with me. So as many of you know, what we do is we initially collect the cerebrospinal fluid data from those of you who volunteer for that part of the study through a procedure called a lumbar puncture. And what we then do is we take that data and we store it for a bit in our freezers in the hospital, and then we actually batch it all together and we ship it over to Sweden to our collaborators over there who are experts in cerebrospinal fluid analysis. And they then assay these samples for particular proteins, those that are associated with beta amyloid plaques, neurofibrillary tangles, as well as general neuron health or brain cell health. And then we get back lots of numbers, lots of data that we get to have fun analyzing and trying to understand and learn more about this disease. So what do we see with these data in Alzheimer's disease? What we see is reduced levels of beta amyloid protein. And the reason for that, it feels a little counterintuitive, but the reason is actually that the beta amyloid protein is getting stuck up in the brain into those sticky plaques. And so it's not coming down into the fluid, so we see lower levels. And conversely, we see higher levels of the tau protein, which is associated with those neurofibrillary tangles. So this is a way that we can really get a measure of what's happening in the brain by looking at this fluid. And our goal is to try to really move the window of time backwards to see if we can identify these particular patterns of changes in individuals when they're still asymptomatic, so before any clinical symptoms emerge. We're also interested in looking at other biomarkers of neuronal health, including things like neurofilament light protein, neurogranin, things that are helping us to understand how the brain cells change with Alzheimer's disease. Additionally, we're looking at things like inflammation, which we know is important and goes along with Alzheimer's disease. So I'm going to just try to walk through, kind of tell you a story of some of the findings that have come out just over the past year from the ADRC CSF samples. So one of our first projects was to look at how the CSF markers related to those amyloid scans that Dr. Johnson talked about. And so what we found was that amyloid in the CSF fluid is related to brain amyloid in the PET scans in particular patterns. So we see plaques developing in areas that are really important for memory and other higher order thinking. And we can actually see this in the very early stages. So these studies were in individuals who are cognitively healthy, and we could still see associations between proteins in the cerebrospinal fluid and amyloid changes in the brain PET, the amyloid PET scans. Another set of studies looking at brain health and the cerebrospinal fluid found that higher levels of the Alzheimer's disease proteins in the CSF was associated with more disconnections between brain regions, so worse white matter integrity. And one of the interesting things that we found is that more inflammation from some of those inflammation markers in the CSF was associated with worsening or progressive white matter changes over time. And what that tells us is that having more inflammation is associated with more disconnection between brain regions in individuals who are at risk for Alzheimer's disease. And we also found this in another study looking at a particular area of the brain cells called myelin, which is another marker of our white matter integrity or white matter health. And we found that those individuals who were cognitively healthy but had higher levels of these Alzheimer's related biomarkers in their CSF had accelerated degeneration in this myelin with age over time. So again, showing that these increased Alzheimer's markers in the CSF is actually associated with more disconnection between brain regions over time or with age. And finally, we were interested in vascular health, how cerebral blood flow is associated with Alzheimer's disease. And so one of our later studies looked at the relationships between elevated amyloid in the brain and found that there was reduced cerebral blood flow from some of those images that Dr. Johnson showed earlier. So suggesting again this real connection between cerebrovascular disease or vascular health in your brain and Alzheimer's disease pathology. So our next question, after understanding how the CSF markers just relate to brain markers overall, was to understand, can we use these CSF biomarkers to predict how someone will change over time on some of the clinical or cognitive measures that you all come in and do? These are those paper and pencil tests that everyone really loves. Overall, what we found was that people who have markers of amyloid in their cerebrospinal fluid actually showed significantly greater rates of decline across several of the measures that we gave on both memory and some of those executive functioning or problem-solving measures. Whereas individuals who didn't have markers of the amyloid and tau, or just had markers of tau but no amyloid, were kind of just stable on these different paper and pencil measures over time. And these were all actually cognitively healthy adults in the study. So this suggests that the amyloid, when we can detect it really early, we can actually predict how individuals may be at higher risk for further decline. And this is just another study. I'm not going to go into it, but